This is for Year 12 methods. It comes out of the 2017 probability tests SAC question number 5. Topic test question number 5. Consider the following graph of a restricted function f of x. Mr. Molino thinks it may be useful to predict the probability of photons of light hitting a sensor in an experiment. Okay, so having a quick look at this particular thing, it seems to be touching at -1 through to 1, perfectly symmetrical. That makes sense because it's a cosine curve. Therefore, I'll be thinking that my mean is 0, my median is 0, and my mode is 0. Mode is the highest point because it's perfectly symmetrical on its side. I need to show that A equals a half and S equals 1. Cannot use the calculator. Got to do it by hand. I've got to come up with these answers myself. I notice that there's a point there, 0, 1, so I sub in 0, 1. 1 is the y, 0 is the x, cos of 0 is 1. 1 plus 1 is 2, divide by A equals a half. I'm going to put A equals a half into the equation, then sub in another point. I chose this one, which means I have a half 1 plus cos of pi on s. Since I've got the null factor law, either this equals 0 or this equals 0. When 1 plus cos of pi on s equals 0, the -1 goes across. -1 is over here, therefore theta is pi. Pi equals pi on s, s equals 1. Part B, they're all equal to 0. I can find it out through symmetry. Write a definite integral that represents the probability of x being greater than pi on 6. Pi is about 3.142, on 6 it's around about a half, so we're looking at this area here, and the definite integral would be pi on 6 to 1 of a half bracket 1 plus cos of pi x close bracket dx. And part D says find that probability, so I select it, math 2 integral from pi divided by 6 through to 1, because 1 is the restricted domain, dx, and there's my answer. And I needed to give that to 4 decimal places, so that's going to be my answer. Always write the answer out to much longer and then approximate to 4 decimal places. I've got a conditional probability here. I want less than pi on 4, so this is pi on 4. Here is pi on 6. Less than pi on 4, given that it's bigger than pi on 6. So the overlap, the intersection, is the area in between, and then that's on my bottom. So what I might do is I might bring up a fraction. I'm going to bring up a fraction. I'm going to put that into the denominator, and into the numerator I'm going to put from, I will copy that. I want to go between pi on 4 to pi on 6, don't I? So I'll paste that there, from pi on 4 to pi on 6. And that's going to be pi on 4 to pi on 6, pi on 6 to 1. Of course, I want pi on 6 to pi on 4. And that's going to give me my answer there. And the second part, I want the probability that's bigger than pi on 4, given that it's less than pi on 6. There is no intersection area, so I get a 0, therefore the probability equals 0.